Okay, welcome to the next lecture. This time we're going to talk about expert parallelism in SimpleFSDP. So traditionally with transformers, we have input, they go through retention, then we typically do a norm, RMS norm is the most common, and then we do a feed-forward network, and then we keep going. For MOE, we replace the feed-forward with what's called a mixture of experts, where we have multiple experts, and we do this token routing to figure out which expert to go to. And then with expert parallelism, we take this further, where we kind of shard the experts across multiple GPUs. So in practice, what this means is after the tension and the norm, we have this step where we kind of distribute the tokens to different experts based on which expert does best for that token, and then we'll redistribute back later. Okay, let's take a look at the code. So everything happens within this apply MOE EPTP function, and you'll see here that there's a little bit of indirection, but the basic idea is that we're going to call this parallelize module function, and we're going to pass it a plan. In the case of expert parallel, it's this expert parallel plan. And if we jump to what expert parallel does, that previous function we'll end up calling apply on the MOE modules. So now might be a good time to look at the actual model. So this is the transformer block. And as we saw previously, in our forwards, we do an attention. And then if MOE is enabled, we do a norm, which is an RMS norm, followed by MOE. And if it's not enabled, we do feed forward. Now, what is MOE? So MOE, there's experts, there's a router, and basically this is all the machinery to figure out, which expert to route to, and then do the actual expert computation. And then there's some shared expert stuff. Now, if we go back to this parallelize, we see that we call parallelize module, and we only parallelize the transformer block.moe.experts. And so if we go back to expert parallel, you'll notice that when we call apply on the experts, first of all, like this quote unquote dot experts is this grouped experts module. And then second of all, what this does is it effectively it does three things. So the first thing it does is it shards the parameters. So you can see here we're assigning D tensors that are sharded for the parameters. And the second thing it does is it applies these hooks. So input FN becomes a pre-forward hook, and output FN becomes a post-forward hook. And what the input FN does is it does token dispatch, where at a high level, what all of this code is doing is basically this part right here, where like it's figuring out which tokens go to which GPUs. And indeed, we won't do it here, but if you breakpoint here and you print out routed input, you'll actually see that it's different per rank, and it's due to all of this logic here. And once this, so this is a pre-hook, right? So this return value will basically be the input to the forwards of this grouped experts forward. So you can see this correspondence here where like, routed input corresponds with X, and the num tokens per expert is the num tokens per expert. So then once you get to this grouped expert, we're just gonna do it as if it's a single node. And then once it's done, we're going to go to this output function, this post forward hook. And this is going to effectively like reroute the tokens back to the original sender. And yeah, like at a high level, that's kind of what's happening with expert parallelism. Obviously, we skipped over a lot of the code, but hopefully this gives you kind of a high level intuition as to what's going on, where we're primarily parallelizing across this last component of the transformer. We're doing this token routing, and we're utilizing detensors for the parameter sharding. And then lastly, we're using these like pre and post forward hooks to do the token dispatching and aggregation. So hopefully this gives you a better intuition. I went through it very quickly, but hopefully it gives you at least the code pointers to read through the code more deeply. And maybe in future lectures, we'll deep dive into particular areas of the code. So thanks for listening.